In Yellowstone, the large volumes of dilute rain and snowfall, meteoric water, that seep into the ground contain almost no silica. After percolating to depth, the water is heated by the underlying magma and mainly flows through layers of rhyolite, which is the most abundant rock in Yellowstone. Rhyolite contains a lot of silica, about 75% by weight. When the hot groundwater and rhyolite react, silica is removed from the rhyolite and dissolved into the water, similar to how water dissolves salt or sugar. Laboratory experiments, many of which were conducted by the late USGS scientist Bob Fournier and his colleagues, showed that the hotter the water, the more silica it can contain. As it ascends towards the numerous hot springs in Yellowstone, the groundwater cools. The neutral to alkaline waters that are common in the geyser basins typically contain up to 400 milligrams of silica in 1 liter of water, equal to about 0.1 teaspoons of silica in a quart of water. Thus, a significant amount of silica is added to groundwater along its flow path between where it falls as snow or rain with nearly no silica and where it re-emerges at the surface in hot springs. When water flows away from a hot spring or erupts from a geyser, it further cools and evaporates, and the amount of silica it can hold decreases. This leads to the precipitation of opal, which is an amorphous form of silica, a solid with no crystal structure. Through many thousands of years, opal crystallizes to form minerals that have the same chemical composition, CO2, but have different crystal structures, polymorphs. The final mineral to be formed in the crystallization process is quartz, which is the most stable form of solid silica at room temperature.